We ended our last video on horizontal compressions and stretches. Now I want to talk about what happens when we multiply a function by a negative. So here I have the function x squared, and here I'm letting g of x be equal to negative x squared. Let's see what happens when we have this negative on the outside of x squared. So here's the graph of x squared. Let's write a few points. Here's 0, 0. This is 1, 1. This point right here is negative 1, 1. This point is 2, 4. And this one is negative 2, 4. Zoom in a little bit to make that a little bigger. Now let's graph this function. We're going to plug in some points. What happens if I plug in 0 for x? Well, I'm going to get 0 for g of x, or y. So I'll have a point at 0, 0. In fact, let's do this in red to go with this function. What happens if I plug in the value 1 into x? Well, 1 squared is 1, and then I multiply it by a negative, I get negative 1. So 1 goes to negative 1. If I plug in the value negative 1 in to g, well, I'm going to square it, and it's going to give me a positive 1, and then I multiply it by a negative. So I'll get negative 1. So negative 1 will also go to negative 1. So I'll have this point right here. Plug in 2. 2 squared is 4. Multiply it by a negative. 2 goes to negative 4, and you'll see that negative 2 also goes to negative 4. So we can draw this graph now. Looks something like that. I'm going to plot these points. Sorry, I'm going to write the points beside the points here. So this is 1, negative 1. This is negative 1, negative 1. This is 2, negative 4. And this one is negative 2, negative 4. Let's compare these two graphs. What do you notice? Well, this graph flipped about the line y is equal to 0. So when we multiply a parent function with a negative on the outside, so outside of this x squared part, that corresponds to a reflection along the line y is equal to x. Now let's also compare this parent function here, f of x is equal to x squared. Let's compare it to negative x squared. Now notice where I put the negative compared to this last one. So here I had the negative on the outside of this x squared. Now my negative is on the inside. Okay, so let's see what happens. If x is 0, then let's call this, I don't want to call it f because this one we're calling f. So let's call this h. Okay. So if x is 0, h of 0 is negative 0 squared, which is just 0, so we have a point at 0, 0. Let's put that in green. If x is 1, then h of 1 is negative 1 squared, which is 1. So we have the point 1, 1. If we plug in negative 1, we get h of negative 1 is 1 squared, which is 1. So we have a point here. And you'll see if you plug in 2, you'll get 4. And if you plug in negative 2, you'll also get 4. So our graph looks like this. So let's compare this one to our original function here. What do you notice? Well, these graphs look the same. So it's not that putting this negative here didn't change the graph. It actually did change the graph. It happens to be that you're going to reflect your graph along the line x is equal to 0. But since this graph is symmetric with respect to this line x is equal to 0, or the y-axis, then nothing's going to change with this graph. You might have noticed that when I plugged in 1, well, this was sent to -1 on the inside. So this 1 here is being sent to -1. So these points are being reflected. So let me summarize what's happening. If you have a function and you put a -1 on the outside of that function, it reflects it about this line y is equal to 0, or in other words, the x-axis. If you put the negative on the inside of the function, it's going to reflect it about the line x is equal to 0, or the y-axis. So negative on the outside, reflect about the x-axis, negative on the inside, reflect about the y-axis. Now, because this graph was actually symmetric with respect to the y-axis here, in other words, it's an even function, we didn't see any change. But with other functions, we will see a change. So what's the difference between these three equations? Well, g of x is negative f of x. You can see the negative is on the outside. And h of x is f of negative x. So the negative is on the inside of the function. So if we have a parent function, if we put a negative on the outside of the parent function and call it g of x, this represents a reflection about the line y is equal to 0, or the x-axis. So negative on the outside, reflection along this line. If we put the negative on the inside of the parent function, this represents a reflection about the line x is equal to 0, or the y-axis. Let's look at another example. Let's compare the graphs of these functions. Here I have f of x is equal to negative square root x, and g of x is equal to the square root of negative x. I want to call this, instead of f, I'm going to call it h. And I'm going to let my parent function be the square root of x. Okay, let's graph square root of x. Well, we have to remember what that looks like. The square root of x goes through these 3 points. I'm going to write them on this graph, 0, 0, 1, 1, and 4, 2. And those are the same points right here. Okay, this negative is on the outside. H of x is negative f of x. And we said that corresponds to a reflection along or about the line y is equal to 0. So that's what we're going to do. We're going to reflect this. So 0, 0 stays here. This goes to 1, negative 1. So it was originally 1, 1. Now this is 1, negative 1. then this 0.42 goes to 4, negative 2. See here it says negative 2. And then we can now draw the line like this, the curve. Oops, it didn't go through the point. Like that. And erase the original function. Let's double check some of these points here. If I plug in 1 into my function, I get the square root of 1, which is 1, multiply it by a negative, I get negative 1. If I plug in 4, the square root of 4 is 2, and then the negative makes it a negative 2. Now let's look at this red function. Notice that this is equal to f of negative x. So I'm plugging in negative x into this function here, f, and that gives me g. When the negative is on the inside, it's a reflection about the line x is equal to 0, or the y-axis. So we leave this piece here. 1, 1 will go to negative 1, 1. Reflect this point. This point, if you reflect it, goes to negative 4, 2. And now we're going to attempt to draw the curve that goes through these points here. It's going to look something like that. And now we're going to erase the green parent function. And this is our function g of x. Let's double check some of these points. Plug in 0. Well, negative 0 is 0, square root is 0. Plug in negative 1. Negative of negative 1 is 1, square root of that is 1. Plug in negative 4. You'll see that you'll get a positive 4, and the square root of that is 2, right? Square root of 4 is 2. Okay, so we do have indeed the right graph. Let's talk about the domain and range of these graphs. That'll be something fun to do. So let's see if we can find the domain and the range for both of these. For this graph, h of x, we can just look at the graph and we see that the domain is going to be from 0 to infinity. Remember, domain is the x values. And the range is going to be from negative infinity, because this is going downward. It's going to continue to go downward. So the further and further you go, it's going to be way out here, but we're still going to have a point on the line. So this is going from negative infinity, and as we go up, the last point we're going to have is 0. We can equal 0, and all of there's not going to be anything up here, so we don't worry about anything above 0. And compare this to the domain, the range of the normal square root function. Normally the domain is 0 to infinity, but the range is 0 to positive infinity. And because we have this negative here, it flipped all of our range values, which is why the infinity is now negative infinity and 0 stays 0. Now let's look at the domain and range of this one. Now this negative, when we plugged it on the inside, it changed the x values. So to start off with the range of this function is not going to be different from the range of the normal square root function. So the range is still 0 to infinity, just like if we had the regular square root function. Okay, you can see the lowest number for the range on the y-axis is 0. This is going to be going upward, so this is from 0 to infinity. This negative on the inside changes the domain. Notice that the domain here, well, remember with square roots, whatever's underneath the root has to be greater than or equal to 0. So I have negative x is greater than or equal to 0, which tells me if I multiply both sides by a negative 1, it switches the sign, and x has to be less than or equal to 0. So the domain is negative infinity to 0. And you can see that in this graph, because the further and further you go out, well, this is going on like this. So no matter what negative value you have, it's going to be on this graph here. We're going to have a point corresponding to that x value. And then once we get to 0, anything above 0 on this side, there's nothing pictured here. So we don't have any x values that are greater than 0. Let's move on. Now I want to talk about series of transformations. So we're going to look at some transformations, and we're going to do several different transformations. So we're going to have vertical shifts, horizontal shifts. We might have vertical or horizontal compressions. We could have a reflection. Any of these things you might see. We're going to go slowly, and we're going to do several examples so you'll be able to do them on your homework. So I want to graph this function. G of x is 1 over x minus 2 plus 3. Okay, I'm going to graph it on this plane. First thing you want to do is you want to look at this function and compare it to your parent functions that you know. What function of all the functions that I asked you to memorize does this look the most like? And you'll say it looks like the reciprocal function, which is 1 over x. We're going to graph this first. So we need to graph a couple of points on this graph here. So if we plug in 1 over 1 is 1, so we're going to have a point at 1, 1. You can plug in 1/2 if you want, and you'll see that you get 2. And if you plug in 2, you'll get a half. So your graph, I just want to try to draw something as close to what the graph looks like as possible. So it looks something like this. Just review the graph if you don't remember. Just look back at your notes. So this portion is like that. And then we also can plug in negative values. The only value we don't have in the domain is 0. So if I plug in -1, I get a point at -1. If I plug in -2, I get -1/2. And if I plug in -1/2, I get -2. So this is a function that's symmetric with respect to the origin. So I'm going to go down like that. And this is going to go upward and get really close to 0 but not touch it. So something like that. So this is what 1 over x looks like. And I'm going to put f of x here. Again, draw this in pencil because we're going to change this. Now I'm going to define a new function, and I'm going to define it in blue. And I'm going to call it f sub 1 of x. And sometimes I don't say sub 1, I'll just say 1, f1 of x. And I'm just going to choose some way to manipulate this. Notice that I have two things that are different. I have this -2 and I have this 3, and I just choose one of them. So I think what I'm going to do first is I'm going to take this function and I am going to plug in x minus 2 wherever I see an x, because that will give me 1 over x minus 2, right? So I take the original function, I plug in x minus 2 where I see an x. Well, I get this piece. Okay, and then we're going to take care of this 3 in just a second. Let's graph this piece first though. So here I've plugged in x minus 2 into the function. Remember that that corresponds to a horizontal shift. This -2 means we go to the right 2 units. So these 3 points I made, we're going to move them over 2 units. So this is 1, 2, 1, 2, then 1, 2. And now we're going to try to draw this. And see this asymptote here? This asymptote is also moved over 2 units. So now this asymptote, I'm going to draw it right here, just so I have a visual clue of how this graph's going to look. It's going to go really close to that asymptote. And the asymptote here doesn't really change, okay? And then this point is moved over 1, 2. This point is moved over 1, 2. And this one is moved over 1, 2. Okay, it looks something like that. So let's erase the parent graph, because we don't need it anymore. Great. So now we have the graph of f of 1 of x. Now I want to graph f2 of x, which is taking f1 of x, and I'm going to add 3 to it on the outside, okay? If I do that, that says I'm taking 1 over x minus 2, because this is f1 of x, and then I just add 3 to the outside. So this function that I've made is now equal to the function I wanted to graph. So because I put this plus 3 on the outside, that means I'm going to move up 3 units. So each one of these points, they're going to move up 3 units. So 1, 2, 3. This one goes up 1, 2, 3. And same thing with this one, up 1, 2, 3. And this asymptote's not going to change. This asymptote, because I need to have an idea of where this ends, let me erase this piece right here. This asymptote needs to move up 3 units. So let's go here where it's easier to see. So 1, 2, 3. So now this is the asymptote. Sorry, let's draw it here. Make this a little bit clearer. Then we can keep it going this way. And now we're going to make our line go pretty close to that asymptote. And I can erase this piece now. And now I'm going to move this one up 3. So I take my 3 favorite points, go up 1, this might be hard, 1, 2, 3, so right here. Be very careful, 1, 2, 3. And then this point here goes 1, 2, 3. I can erase this now. And I'm going to connect these points. Remember, I'm just trying to give a good sketch of what it looks like. It's going to look something like that. And so this is going to be my final picture. I want to erase this here. This kind of looks messy, so I'm going to erase that as well. And let's double check. Let's just plug in one of these points to see if we got something correct. So how about the number 3? This point looks like 3, 4. So if I plug in 3 into g, g of 3 is 1 over 3 minus 2 plus 3. I'm just plugging it in wherever I see an x. I get 1 over 1 plus 3, which is indeed 4. And you can try the other points as well, and they should line up. So if you plug in the right x value, like this one here, 1, if you plug in 1, this will become negative 1, which will give you 2, which does go with this point here. Let's try to graph this function. H of x is 2 times x minus 1 cubed minus 1. Okay, this one has 3 transformations. We're going to have to do 3 transformations for this. So we need to first pick our parent function. We have to remember our list of parent functions and see which one this looks the most like. Well, this kind of looks like x cubed. Let's draw that function. So x cubed goes through 0, 0, goes through 1, 1, and it goes through negative 1, 1. And we can do some more points too, like 2, 8. But the graph is going to look like this. And I would make my points pretty big so they're easy to see here. Now, of course, if you did more tick marks, depending on how you space your tick marks here, your graph might look a little like this might be down somewhat, but it's going to take this kind of, I guess you could say it's like an S-shaped graph in a way, like on its side. It's kind of like an S. Let me think about what an S looks like. I guess like a S flipped. Anyway, it's curvy. It's a curvy graph. So half a parabola and then another half flipped. Okay, now we're going to think about the steps we need to take. Now you really can do them any way you want, but you need to be careful. So I'm going to start. I think the first thing I want to do is I like to take care of this inner transformation. So what I'm going to do is I'm going to take my parent function f of x, and instead of x I'm going to plug in x minus 1, which gives me x minus 1 cubed if I plug that in, right? And that looks, we're getting closer to this function h of x, because that's what I want to graph eventually. So x minus 1 cubed, well, I've plugged in negative 1 into here inside the function. That corresponds to a horizontal shift. So I'm going to move my graph to the 1 unit to the right. So my 3 points, I'm going to move them all over 1. Then I'm going to try to sketch the graph here. Looks something like that. I'm going to try this piece again. Okay, now we can erase the parent function, and I'm going to label this f1 of x. Now I'm going to choose a different color. I'm going to go with red, and I'm going to make a second step. This is 2 is for my second step. And I'm going to take this function f1 of x, and what am I going to do to it? Well, I have a couple of options. I want to make this look like this one, so I can either subtract 1 or I can multiply by 2. So you have to be very careful here. What I'm going to do is I'm going to multiply by 2. So I'm going to take this function, I'm going to put a 2 on the outside. And I'm going to tell you why I did that. I'm going to show you how you can make a mistake in just a second. But let's go this way first. So I'm going to take this function and multiply by 2. So if I multiply this by 2, I get 2x minus 1 cubed. Okay? So that means I'm going to stretch this. This is a number on the outside of this function. And remember, if it's on the outside and the number is bigger than 1, it's a vertical stretch, which means I'm pulling it, anything that's above this line here, I'm pulling it upwards, and anything below, I'm pulling it downwards. So I'm just going to take all my y values and multiply them by 2. So here my y value is 0. So this is the 0.10. This is the 0.21. So if I multiply my y value by 2, it goes here. So this is going to stretch like this. And this point is 0, negative 1. If I multiply it by 2, it goes to 0, negative 2, which is right here. So I'm going to go like that. And now we can erase our function f1. Okay, great. So now we've taken care of all of this. The last step is to take care of this negative 1. So this third piece is taking f2 and subtracting 1 from it. That will give me my function h of x, which is 2x minus 1 cubed minus 1. Just taking what I had here, f2 of x, and subtracting 1. So this is h of x. So this is going to be my last graph, and I'm going to move it downward 1 because it's on the outside of the function. So all of my points are going to go down 1. Let me zoom in a little bit so I can see it better. So down 1 and then down 1. So it's going to have the same shape, it's just shifted down. So it's kind of like parallel to this graph. Okay, so let's erase this one and erase these points here. Alright, I'm going to make these points a little bit bigger, and I'm going to do some double checking here. So this point is 1, negative 1. This point looks like 2, 1, and this point is 0, negative 3. Let's see if I got the right graph. What happens when I plug 1 into this function here? So h of 1 is 2, 1 minus 1 is 0. This becomes 0 and I get negative 1. I did get this point 1, negative 1. You can plug in 2 for the next one just to see if you get something correct. If I plug in 2, I get 2 minus 1 here, which is 1. This just becomes 2 minus 1, which is 1, and I did get the point 2, 1. Plug in 0, you'll see that you get this point. So we get the right graph. Now, we did everything right. This is great. I want to show you where you can make a mistake. And that is right here. Let's say that we graphed this function f1 of x, which is f of x minus 1. We moved that graph, so I'm just going to remind you what it looked like. It looked like this, I believe, because we moved that graph, the parent function, over 1 unit. And then you could say, well, see, what I did was I multiplied by 2. That's how I defined the second function. I said f of 2 of x was 2 times f of 1x. Okay. Let's say instead I defined this function as taking this one and moving it down 1. So I say let's take f1 of x and subtract 1 to get the function x minus 1 cubed minus 1, because that's kind of similar to what I have. I don't have this 2. So why can't I do that instead? So you take this blue function here and you move it down 1. Okay, so you say go here, this point goes here, and then this point goes here. So I'm going to erase this blue line. And we now have this function look something like this. Okay, and then you say, oh, well, my last step is to multiply by 2. So then we're going to take f3 of x and say, oh, all I need to do now is multiply by 2, and this is where you're going to make your mistake. Say this is equal to f of 2x. Well, if you multiply this thing by 2, you're multiplying this piece and this piece by 2. So you're going to get 2x minus 1 cubed minus 2, because you're taking this whole function and multiplying it by 2. And this is not equal to negative 1. So you can't actually do that. You can't do them in any order. You have to be careful about the order. And you can see what would happen if we multiplied by 2. So if you draw this graph, I have a lot of, let me zoom in. So let's see what happens when we multiply by 2, because we know that this black graph is the correct one. And we said that we had these 3 points here. Well then, if we multiply by 2, well, the y coordinate would stay here. This one, this is the point 1, negative 1. It'll become 1, negative 2, which means we're going to move here. And this is negative 2. It'll become negative 4. So what you're going to end up with is this graph here, which is not the correct graph. The correct graph is this one right here, this black one. And you can plug in these values. You see, you're not going to get the right values when you plug them into H. So you can't just do them in any kind of order. You need to be very careful. So I would say that's why I'm defining this as f1 of x, f2 of x, and f3 of x, because I want to make sure that what I do to this function eventually gets me to this one. Okay, so it's just going to take some practice, but you do need to be careful and you need to write out all these steps. So to summarize, you can't just do them in any order you want to. You have to be careful and you have to double check that what you're doing is giving you the function you want. let's try this one. J of x is equal to the square root of 1 minus x plus 4. What is the parent function? The parent function is the square root of x. Let's draw that. Okay, looks something like that. That's f of x. Now what can we do to get this one to look like this one? I'm going to define a function f1 of x. Now let's think. What's something I can do? I'm going to take this function. Now you can try different things. I think the first thing I'm going to do is I'm going to put a positive 1 in here. So x plus 1. And you'll see what I'm going to do in just a second. How I'm going to make this a negative. So if I plug in x plus 1 into this, what's going to happen? I'm going to get the square root of x plus 1. Not exactly what I want, but this negative 1 minus x is the same thing as negative x plus 1. Okay, so I have the plus 1. I need to make this negative, and I'll take care of that reflection in a few minutes. But this is going to be the function I want to graph now. So I'm going to move this graph because I put it on the inside of the function and it's positive. I'm moving it to the left 1 unit. So all of my points are going to be moved over 1 unit. Let's try that one more time. There we go. So now I'm going to erase this graph. And this graph, the blue one, is f1 of x. Now I'm going to graph f2 of x. And what I'm going to do is I'm going to plug in into f1 negative x. And that will give me, so wherever I see an x, I'm going to plug in negative x. So this is negative x plus 1. And that is a reflection, but it's a reflection about what axis? The negative's on the inside, so it's a reflection about the y-axis. So this point now goes here. This point stays. I think I lost a point here, but that's okay. We had 4, 2, and it went here. So then this point now goes to 3, 2, which is right here. And now we're going to connect them to make it look like that. Make that bigger here. And we can erase this graph. And now this graph is f2 of x. Okay, now we're almost done. We have this piece now because that's the same thing as negative x plus 1 if you just rearrange that, right, using this. So all we need to do now is we just need to make a new function which takes this one and we add 4 to it. Okay, so that will give me the square root of 1 minus x plus 4, which is this function j of x that I wanted. So move all of these up 4 because the 4 is on the outside. So 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And then we connect them. And we can erase this, and we can call this function j of x. And let's just do some test points to make sure we got the right thing. Notice that this point right here is 1, 4. Plug in 1, we get 0. So the square root of 0 is 0, and we get 4, which is correct. That is a point on the graph. If we plug in 0, we get the square root of 1, which is 1, plus 4, that's 5, and that's on the graph. So I got the right graph. Now, when I was making these functions here, I could see what I needed to do next, and that's because I've had a lot of practice when it comes to this. Now, you might not see it so quickly, so you might choose different things to do first. So, for example, let's say, I'm just going to give you some examples of what you can do. Now, there's several different things you can do, but if you do them correctly, you're going to end up with the same graph. So let me show you something else you could do. Let's say you didn't see the first thing you need to do is add 1. Let's say, oh, I have a negative x. That's the first thing I want to do. So I want to plug in negative x in here, and I'll get the square root of negative x. And that gives me this piece. And that's perfectly fine. You can do that. But then you're going to have to define your second function. And so you're going to say, what can f2 of x be equal to? And here you have to be careful, because you took care of this negative. Let's say you want to take care of this positive 1. So you say, oh, well, let me take f1 and add 1 to it. You're going to get the wrong graph. And that's because, let's see what happens when we plug in x plus 1 into here. You'll get, because this is f1 of x, you'll get the square root of negative x plus 1. Wherever we see an x, we plug in x plus 1, and we'll get the square root of negative x minus 1, which is not what we want. We want a positive 1. So if you had decided to take the reflection first, what you should do is, instead of putting a plus 1 here, you need to put a minus 1. Because when you put that minus 1, this negative makes it a plus 1. And that would correspond to after you took your parent function and you reflected it. So you have your parent function, you then reflect it for this graph, which looks something like that. I'm just trying to do this quickly. And then you move it, this plus, you had this minus 1, so you move it to the right 1 unit. So then this is going to look like that. And then you would define your next function, which is to add 4. And then you see, if you make f3 to take this function f2 and add 4, you're going to get the same graph, because it's just going to shift it up 4. So that's just another way to do it. And you're going to get the right answer, you just have to be very careful. Here's another problem. K of x is equal to negative absolute value 3 plus 1/2 x. And I think this is the last one I'm going to do, involving these parent functions. So we have to come up with a parent function. Let's go with the absolute value of x. I'm going to draw the parent function. Okay, so this is f of x, and I know it goes through 0, 0, 2, 2, and negative 2, 2. Now, let's define the next function. I want it to make it look like this. What I'm going to do is I'm going to take care of this 3 first. So I'm going to take f, and I'm going to add 3 on the inside, which will give me x plus 3. Okay? I suggest always doing horizontal shifts first. All right, so plus 3 means I move it to the left 3. So this point over 3, this point over 3, this point over 3. Again, I'm just going to sketch the graph here. As long as I get the majority of it right, that's important. Okay. Erase my parent function. Give me just a second to plug my computer in. It's on low battery. Okay, so what's the next step? I am going to plug in the 1/2 next. So f2 of x is going to be f1 of 1/2 x. And if I do that, wherever I see an x in f1 of x, I plug in 1/2 x. You can see we're almost there. What does this 1/2 do? Well, the 1/2 is on the inside of the function, which corresponds to a horizontal, either a compression or a stretch. And it's going to be a stretch because it's between 0 and 1. So I'm going to multiply all of my values by 2. Okay, so this is could be difficult. Let's just see what happens. So you see how this y value is a 2. I want to get 2 here. So what I'm going to do, I'm going to plug in, okay, so we're going to multiply our x values by a 2. So this is -1. Remember that it's a stretch, so it's pulling all the stuff that's over here. It's going to be pulling it this way. So we take our x values, which this one is -1, multiply it by -2, a +2, you go here. This is -3, multiply it by 2, we get -6, and so on. So this becomes a graph like this. And then this was -5. This point is -5, 2. So then the x value now becomes -10, 2, which we don't see, so it's way out here. So I'm just going to draw like that. Okay, and I'm going to erase this graph. We can double check this as well. We can just plug some stuff in. If we plug in, so see what happens when I plug in -2. If I plug in -2 into this function, I get -1. -1 plus 3 is 2, which is right here. If I plug in -6, I get -3. -3 plus 3 is 0. The absolute value is 0. So you see what I'm doing here? When the number here is inside the function, you're going to multiply your x values by the reciprocal. I think this is actually going to be, if you understand this, this is great, because this is going to be tougher than any of your homework problems. All your homework problems are going to be much easier than this. Okay, so then we almost have our graph. The last thing, the difference between this function, this one, is we have a negative on the outside. So our last function is going to multiply this one by a negative. And the negative is on the outside, which means I flip it with respect to the line y is equal to 0, or the x-axis. This point is -2, 2, so that becomes -2, -2. All my y values change. And we said that this point was, I think we said this was -10, 2, and that will become, way out here, a -10, -2. Yeah. So this is going to be our final graph. Let's try to draw a straight line. And we can erase this one. And then we just double check some points. I claim that -2, -2 is on the graph. Plug that into the function. 1/2 of -2 is -1. 3 plus a -1 is 2. absolute value of that is 2, then we have negative, so it makes it a negative 2. Plug in negative 6, you'll get 0 here, and you see you get 0 for your y value. And then if we plug in negative 10, you get negative 5. 3 plus negative 5 is negative 2. And the absolute value of that is 2. And then you have a negative, which makes it negative 2. So we have the right graph. Oh, that was a lot, but I hope you understand it. The very last thing I want to do in this section is I want to give you a function that is not one of these parent functions. I'm just going to give you something very strange looking. Here's a function. Again, it's a function because it passes the vertical line test. And I am giving you 4 points on this graph for sure. This point is negative 4, negative 2. This point is negative 2, negative 2. This point is 4, negative 2. And this point is 2, 2. So you can see that there's some other points on this graph as well, but definitely 100% sure that these are the other points, some points on the graph. And I want to see if we can do some transformations with this, what we can call a parent function. I've listed several here, but I only want to do maybe 2 or 3. And I'm going to draw them over here. So let's start with, let's go with this easy one, a plus 3. What does that mean I do to this function? This function is f of x. If I put plus 3 on it, what's going to happen to it? Well, I'm just going to take this graph and I'm going to shift it 3 units up. So let's do that. So you see I have each 2 tick marks as a unit. So this is going to go up 2, 3, up 3, and then this is going to go up 1, 2, 3, and this 1, 2, 3. So my graph is going to look something like that. That's part A. Let's do part B. What's g of x going to look like? So this function here, maybe I can write it here. This is f of x, capital F. G of x, which is part B, has this plus 2 on the inside. So that means we move to the left 2. Okay, so we take the parent function. I'm going to erase this so I don't get confused. I take my parent function and I move it to the left 2. So this point is moved to the left 2. This point is moved 2. This point is moved 2. And this point is moved 2. So now I have my graph. Looks like this. And the reason why we're giving you something strange is because I want to make sure that you know what each one of these, the plus 3 and the plus 2, like where they're corresponding. If they're in the inside of the function or the outside of the function, I want to make sure you know what the shifts mean. And here I don't actually give you an equation for the function, so you can't double check. You can't just plug in points and graph it. So I'm forcing you to know how these transformations work. So this is part B, or g of x. Let's try, let's see. I want to do one of these interesting ones. So we're going to do either E or G, and then let's do C, and then let's do E, and that'll be it. So let me erase this. Okay, so for C, we're going to flip with respect to the line y is equal to 0, because this negative is on the outside. For F, you flip with respect to this one here. So what's going to happen? This is going to go here, this is going here, this point goes here, this point goes here, and your graph looks like this. Do you see it? You see how I reflected it along this line? So that's part C. We can do that one as well, just so you see it. The negative is on the inside, so we flip with respect to this line. So this piece goes here, that goes here, this goes here, and then this point goes here. So what you would have is that. You would erase this parent function. I don't want to erase it because I want to be able to do the other problems, but this thing flipped along this line gives you this graph. Now the last one I want to do, let's go with this 1/2 on the outside. So we have a 1/2 on the outside of the function. What is that going to do? Because it's on the outside, it's a vertical stretch or compression. Because the number is between 0 and 1, it's a compression. So we're going to take all our y values and we're going to divide by 2. Okay, when it's on the inside, we're going to take all our x values and manipulate them. Outside y values. So divide this one by 2, that's -1. This one by 2 becomes 1. This is a -2, so that becomes 1, and this one becomes 1. So then the function, oops, looks like this. I'm going to erase the parent function here, and you can see that I have compressed it vertically, meaning I had smushed the graph like this with respect to this line here.